In this topic, we are going to be looking at sequences and series. First, let's look at the general term of a sequence. Okay? The general term of a sequence. Example number 1. Given the general term of a sequence is u sub n equals n plus 1 over n, for n bigger than or equals to 1, find the first 4 terms. Okay, the important terms, we are looking at the general term, and it's given by u sub n. So in my classes, I will sometimes refer to this as just un. Okay, so un equals n plus 1, the whole thing over n. N can take values bigger than or equals to 1. Okay, take note, this general term is sometimes referred to, okay, as the nth term. Okay, so let's look at the solution. You're asked to find the first 4 terms, so which means we have to find u1 the first term, u2 the second term, u3 and u4. Okay, so all you need to do is to plug in the values of n. So in the case of u1, just plug in where you see n, just plug in 1. Okay, so 1 plus 1 in the numerator, in the denominator is just 1, so 2 over 1 is 2. So u2, just plug in 2 for n, so in the numerator we have 2 plus 1, and in the denominator we have just 2, so 2 plus 1 is 3 over 2, and here we have it. Okay, do the same thing for u3, the third term, and u4, just plugging in the values of n respectively and getting 4 over 3 and 5 over 4. So I've written the first 4 terms: 2, 3 over 2, 4 over 3 and 5 over 4. Good. Next example, along similar lines, let's read it. The nth term in a sequence is given by un equals 4n plus 3. Okay, you're asked to find the first 3 terms, in part B the 50th term, and in part C the value of n for which un equals 87. So in part A, we are asked to find the first 3 terms of the sequence. So as usual, we are asked to find u1, u2 and u3. So where you see n, plug in 1. Okay, so the first term, 4 times 1, 4 plus 3 is 7. The second term, plug in n equals 2, so u2 equals 4 times 2, 8 plus 3, 11. And finally u3 will be 4 times 3 is 12 plus 3 is 15. So our first 3 terms of the sequence, 7, 11 and 15. The 50th term, we are looking for u50, just plug in 50. Yeah, so 4 times 50 is 200, 200 plus 3, 203. And finally they ask you for the value of n for which un is 87. So write 4n plus 3 equals to 87. Clean up the equation, so 4n equals to 84, and when you find here, find n, so n becomes 84 divided by 4, n equals to 21. Okay, next we are given the kth term in a sequence is 2k minus 4. So here they did not say general term, they just said kth term. It doesn't matter, it's the same. Okay, they asked us for the first 3 terms, so my solution, I've written uk equals 2k minus 4. So for the first term, plug in k equals to 1, so I have 2 times 1 minus 4 is minus 2. When you want the second term, plug in n equal, or rather k equals to 2, so 2 times 2 is 4 minus 4 is 0. And when you want the third term, plug in k equals to 3, 2 times 3 is 6 minus 4 equals to 2. So the first three terms, minus 2, 0, and 2. In this example, you are asked to find the value of k given the general term and the kth term in each sequence. So you're given some information and you're asked to find k. In part A, un, so let me write it here. Okay, un equals 5 minus 4n. So you know that uk must be equals to 5 minus 4k. And they gave us, in the question uk equals to minus 43. So you write 5 minus 4k equals to minus 43, and you clean this up. 4k equals to 48 and k equals to 12. Okay, that's how you deal with problems like this. Yeah, they gave me un, so uk I just replace my n with a k, and they gave me uk, it's negative 43. Clean up an equation, solve for k, and you'll get k equals to 12. That's part A, and we are done. In part B, do the same. un is 1 plus 2n over 1 minus 2n, and they gave me uk is negative 31 over 29. So I've done it here for you. Okay, I've replaced n with k. So clean up this equation, do some rather cross multiply first. When you cross multiply, you'll get this line. Okay, and you clean this up, use a calculator, and you'll get k equals to 15. Not difficult, yeah? And do the same for part C and part D. So let's go through it. Okay, in part C, you're given un is n times 3n minus 1. So uk will be k times 3k minus 1. So that's what you see here. And uk is given as 234. So when you write this line down and clean it up, you will get a quadratic equation. Yeah. Okay, when you write k times 3k minus 1 equals to 234, and you clean up the algebra, you will get a quadratic equation in k, 3k squared minus k minus 234. You can choose to factorize, or you can use the quadratic formula and work out a value for k. You get two values of k. Okay, k cannot be a negative number, so k equals to 9. Then we have the last part D, same thing. We have 2k minus 1 times k plus 1 equals to 135. Clean up the algebra. Again, we have a quadratic. We have two values for k. One value you get is negative 17 over 2. That's not possible. So we take the positive value of k, the integer, k equals to 8. Okay? Good. And we're done with that problem. So let's look at number 5. Okay? Let's read the question. The fourth and fifth terms of a sequence are 26 and 33. Yeah? So let's write it. U4 is 26 and U5 is 33. And they gave me UN is AN plus B. You asked to find the values of the constants A and B. So let's look at the solution. Yeah? We are given UN is AN plus B, so we can write a few things. Okay, U4. Okay, they gave me U4 is 26, and they gave me UN is AN plus B, so plug in. Okay, so let's write it. U4 will be 4A plus B. So 4A plus B equals 26. First equation. You can also do the same for U5. Okay, it will be 5A plus B. So 5A plus B equals 33. We have two equations. We can easily solve this. Take 2 minus 1, you will get A equals to 7. And you plug in the value of A in one of the equations, and you'll get B equals to negative 2. And let's finish off the problem in part B. Okay. If the 8th term of the sequence generated by un equals an squared plus 3, so they gave me u8 equals 131. So, and they gave me un is an squared plus 3. So I can write u8 will be equals to 8 squared is 64a plus 3. Okay, so 64a plus 3 is equals to 131. This equation you can easily solve. You can find a and you'll get a equals to